Physics 101 Dynamics homework number 15. This one's a little bit complicated, but I'm going to help you get it set up so that you can at least know where to start to work through it. So we have a situation where we have an object, two objects that are attached. In the rope, there's a tension, and that tension is going to act on both boxes. For box number 1, the tension is going to act up. And for box number 2, the tension is going to act along the line, pulling it up the hill. In both cases, it says that it's moving at a constant speed. So the acceleration is 0 meters per second squared. That's important. That means that the forces have to be balanced because F net equals ma. So if A is 0, F net is 0, and that means that the forces left have to equal the forces right, the forces up have to equal the forces down. So I'm going to draw a diagram of the forces acting on each box. For box number 1, we have the force of gravity, which is going to equal mass 1 times g. And then you have the tension force acting up. For box number 2, we have more forces than that. More than just the two forces. We have the tension force pulling it up the incline. We have a gravitational force acting straight down, which is going to equal Fg equals m2 times g. And we have a frictional force going down the incline. It's sliding, so it's going to be F, force of kinetic friction, which is going to be mu for kinetic friction times the normal force. And we also have a normal force that's going to be perpendicular to the surface. Alright, so that's all the forces acting. And those forces are going to balance out. I want to point out that if we look at box 2, the tension force, the normal force, and the frictional force are all perpendicular to each other. They're all 90 degrees. The only one that's not in that same set of perpendicular lines is the gravitational force. So it's here's a little trick for solving problems like this. For box number 1, all the forces are up and down. So we know for box number 1, we have the tension going up minus the force of gravity going down, m1 times g equals m times a. But A is 0, right? So that leaves us with tension equals m1 times g. Since we're trying to find m1, once we find the tension, we just divide it by g, we're going to find m1. Okay, great. But we have to get the tension. And we get the tension from block 2. But it's kind of difficult to deal with the tension, or with those forces on block 2 as they are. Here's where the trick comes in. What if I look at the incline as if it wasn't an incline at all? What if I look at it, block 2, as if it's just sitting flat? So we'll have the frictional force that was going down the ramp, but it's acting to the right now. We have the tension force acting to the left. We have the normal force going up. And we have a gravitational force, I'm going to make it blue, that's going at some angle, theta, that's given in the problem. So that angle theta here is the same as this angle here. So here's our theta. Now that's the only one that's kind of the oddball in this problem. And we know the forces up equal the forces down, the forces left equal the forces right. The y component of the gravity, so this is Fg, and this is Fg y direction. And we're also going to have an x component, which is going to be Fgx. Fg, in this case, Fgy, since theta is where I labeled it, Fgy is going to equal the Fg times the cosine of theta. So Fgy for blocks 2 is going to equal Fg times the cosine of our angle theta. And that is going to equal our normal force. Why? Because the forces down have to equal the forces up. There's only one force down, it's Fgy. Only one force up, the normal force. Now, if we know the normal force, we can use that to find the kinetic friction. And once we have the kinetic friction, we know the forces to the left equal the forces to the right. So to the left, we have the tension force, and that's going to equal the forces to the right, which will be the force of kinetic friction, plus FGX, which FGX is going to be equal to FG sine theta. So that's how you set it up. From there, you've got to do the math, but that's the physics part of it. Let me know if you have any questions.